Hello everyone. In this video we will learn about the elementary transformations or elementary operations on matrices. Also we will learn about elementary matrix and the equivalent matrices. First we learn about the elementary transformations. The first elementary transformation of the matrices is interchanging any two rows or columns. Interchanging any two rows or columns. To learn this, suppose we have a matrix A, the elements in which are A, B, C, D, E, F, G, H, J. This is of order 3 into 3. Suppose we want to perform the operation in them in the rows, interchanging row 1 and row 2. Then the representation of this will be as R1 interchanging with R2, and the matrix which we get after this will be D, E, F, A, B, C, G, H, J. The third row will remain same. Now suppose we want to learn the operation in the columns. Suppose we have another matrix B in which the elements are P, Q, R, S, T, U, V, W, X. And suppose we want to perform the operation in the columns. We want to interchange column 2 and column 3. Then we will represent this as C2 interchanging with C3. And the matrix which we get after the operation will be P, S, V. The first column will remain same. Here this will be R, U, X, and the third column will be Q, T, W. This is the way we can apply the first elementary transformation to any of the matrix. The second elementary transformation is multiplying the elements of a row or column by some non-zero number. Multiplying the elements of a row oblique column by a non-zero number. To learn this, suppose we have a matrix A, the elements in this are A, B, C, D, E, F, G, H, J. And we want to multiply the elements of any of the row of this. Now suppose we want to perform the operation in any of the rows. Suppose that we want to perform in second row. We want to multiply by a non-zero number k. Then we write this as performing the operation in row 2, and that is what? K into R2, where k is not equal to 0. And then the matrix which we obtain will be A, B, C, K into D, K into E, K into F, G, H, and J. Suppose we want to perform the operation in the same matrix in any of the column. Suppose we want to multiply column 3 with P. In A, performing the operation in column 3, and that is we are multiplying with P, where P is not equal to 0. Then the matrix which we obtain here will be A, D, G. The first column remains same. Second column remains same, B, E, H. Multiplying the third column, this will be P into C, P into F, and P into G. The third transformation is adding some multiple of a row or column to any other row or column. That is adding some multiple of a row or column to any other row or column. To learn this, suppose we have a matrix A, the elements in this are P, Q, R, S, T, U, V, W, X. And we want to perform the operation in column 1. We want to add twice of column 2 in this. So we will represent it like this: operation in column 1, that is column 1 plus twice of column 2. And the matrix which we obtain after doing this will be P plus 2Q, S plus 2T, V plus 2W. Q, T, W, R, U, X. The second and third column will remain same. Suppose we want to perform the operation in the rows. At this time we want to subtract some multiple of row 3 from row 2. We want to perform the operation in A only, and that is row 2. The operation is row 2 minus thrice of row 3. This is the representation. And then the matrix which we obtain will be P, Q, R. The first row will remain same. Second row will become S minus 3V, T minus 3W, and U minus 3X. The third row will also be same. This is the way we can perform the third transformation in any of the matrix in the rows or columns. Like this, these are 3 operations or transformations the matrices, but since they are 3 in the rows and 3 in the columns, so we can say they are total 6. 3 in the rows and 3 in the columns. Now let's learn about the equivalent matrices. What are equivalent matrices? Suppose A is any of the matrix and we obtained one of the matrix B after sum of the definite number of operations on that. Then A and B are equivalent matrices. So we can say let A be a matrix and B be another matrix obtained after applying a finite number of transformations on A. Then B is equivalent to A and also A is equivalent to B. The representation of them is A is equivalent to B. Suppose we have a matrix A, the elements in this are 2, 5, 1, 4, 3, 2, 7, 6, 5. And we perform the operation in this, that is, we are performing the operation in C1, that is C1 plus twice of C2. After this, we are getting it as C1 twice of C2, 2 plus 2 into 5, 4 plus 2 into 3, 7 plus 2 into 6, 5, 3, 6, 1, 2, 5, which is equal to 2 plus 10, 12, 5, 1, 4 plus 6, 10, 3, 2, 7 plus 12, 19, 6 and 5. Suppose we perform one more operation in this and then we get, suppose we are performing the operation in this as R1 interchanging with R2. Then it will become 10, 3, 2, 12, 5, 1, 19, 6, 5. And suppose this is the matrix B, then we say that A and B are equivalent matrices. Of course, this matrix, the one which we are getting after the operation, first operation, is also equivalent to A. So like this, after performing any number of operations in any one of the matrix, what are the matrix we are getting, that is equivalent to the given matrix. Now what is an elementary matrix? Actually, any of the matrix which we obtain after a single transformation applied on a unit matrix is called elementary matrix. We can say a matrix obtained on applying a single transformation on a unit matrix is an elementary matrix. Suppose we have a unit matrix of order 2i2, that is, we know 1 0 0 1, and we apply the operation in C1, that is multiplied by 5. Suppose the matrix which you obtain is A, that will be 5 0 0 1. This is an elementary matrix. Another example we can take, suppose I3, that is the unit matrix or identity matrix of order 3, which is 1 0 0 0 1 0 0 0 1. Suppose we perform an operation in this, that is R1 and R2 we are interchanging. Then suppose we get a matrix B, R1 and R2, that will be 0 1 0 1 0 0 and 0 0 1. So here B is also an elementary matrix. After learning about the elementary transformations, we will learn how to find out the inverse of a square matrix by applying the elementary transformations to a given matrix in the next video. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.